Okay, in this video I want to show you the upgrades which I've made to the original Sander Thicknesser. A few suggestions were made from others who had made the Sander Thicknesser from the original video, and I've taken some of those suggestions and upgraded the whole thing, and I've also added a few other things, and I just want to go through those with you, show you how it all works, and hopefully show you the improvements which those changes have made to the machine. Now, first of all, the most obvious thing here, this is now made of box steel or hollow section steel. The principle is pretty much the same, but this will now be the sledge, and this is a piece of hollow section steel which has got a 3mm wall. It's 120 millimeters by 60 millimeters, and we're using that as the sledge. Essentially all I've done with this is, it's a straight piece of steel. I've cut a rectangle out here so I can get my hand in to push it through the machine. So that's the sledge. The table itself has changed. This is also a piece of box steel at this point, and the addition, which was made by someone who had made one of these, a fantastic upgrade this by the way, is the addition of these lugs here. Now, if I spin this round, I'll show you exactly what it is. This is also on a fairly sturdy bench at this point, which is on casters, so it can easily move it around the workshop, because the weight has obviously increased quite a bit through using the steel. These lugs here are going to keep the sledge uniformly straight as it goes through the machine. One of the main problems with the previous model was that the sledge could go like this as it was coming through here, and as the wood was running against the drum, it could make little hollows in it here and there unless you were very, very careful. So the addition of these lugs gets rid of that problem essentially, and makes the whole machine much more accurate. Now, another thing I can tell you is it is powered independently at this point. In this casing here, this is off an old belt sander, and we have a 500 watt motor in here, which is a direct drive with a timing pulley onto the shaft which is turning the drum. Most of the other things about this machine are pretty much the same, but those three things there really have been improved upon. One, the box steel, so there's no warping of the table, it's not going to move anywhere as you're putting the material through it. Second is these lugs, which are going to keep it all nice and straight. Third, independent power from this machine. And I suppose fourth, putting it on a table which can be moved around easily. Now, I can take the camera and show you the various parts of this, just to show you how it's put together, how it's made, and we'll take it from there. Okay, so from the bottom up, what we have here is the adjusting mechanism, first of all. Now this works in conjunction with this thing here, which is essentially a bar which goes through the walls of the Thicknesser itself and straight through the table. The idea of this is we tighten those up when we've got it to the correct height, and that'll stop it from moving at all. So if we slacken those off just for the moment, and I'll show you here, this is the adjustment mechanism. What we have is a piece of threaded bar with a disc on the bottom just so we can turn it easily, and the base of the machine has a nut in there recessed into the base and araldite in so that that can move freely up and down, and that will take the table up or down. Once you've got that in position, you'll just lock it with these things here, and that's going to prevent it from moving if there's any vibration in the machine, etc. So that's the height adjustment mechanism. Very simple, very straightforward. If I spin this a little bit, the other thing I can tell you about this is a piece of box steel, and it's hinged to the back side of the table here. So that's going to pivot that way as we adjust it up and down. Height adjustment mechanism. Now the other thing, a major change with this, is that it is now powered from this old 500 watt motor, and it's powered directly. We used to have wooden pulleys on this, which were never ideal. They worked, they did the job, but they weren't the best in the world. So what we have now is a sort of toothed timing pulley and timing belt, so it's driving the drum directly from this 500 watt motor. Just another point, I've reduced this bar down to 12 mil and obviously replaced the bearings with a bearing with a 12 mil bore. The reason for this, these parts, the pulleys and this type of stuff, not many available with a 20 mil bore. The other shaft was 20 mil and I couldn't really find these, so I've replaced all of this with a 12 mil bore, and these 12 mil bore pulleys are quite readily available. So that again powers the machine much better. It's a much quieter machine, much smoother, less vibration going on with it. Dust extraction remains pretty much the same as it was in the first machine. It's a simple cowling which I've made, put a hole in it. We can stick the vacuum in there and that will catch all of the dust as it's thrown up by the drum. Important to have a dust collector on here. These things do throw out a fantastic amount of dust once you're working with them. So again, this is a very simple thing. It's cut to shape around the bearings. It's a nice tight fit onto the housing, and we can stick a hose into the top of it. So just to show how the whole thing works, first of all, first thing we would do is put the sledge into it. Slide in there. Another thing about this table, it has some brakes on it, which are a very good idea. Stop the thing from sliding about as you're working with it. So we have the sledge in. I have here a piece of maple, thin piece of maple, and I'll demonstrate how the whole thing works using this. First of all, first thing I'll tell you, we want something to stop the wood from being pushed back over as it's going through the machine. So what I have here is just a couple of scrap pieces of wood clamped onto the form. This has taken a curve on as that's been pushed into the machine, and as it's hit the drum, that's taken a curve from the drum, but that's okay. It still supports the workpiece, so to speak. Right, so we would put that under the drum, loosen off that, and then we want to adjust the table upwards, which this one needs to go quite a ways, but we would adjust it just to the point where it has a bite on the wood that we're going to break. That's pretty good. This wood is uneven, and hopefully this is going to even it up. But there's just enough bite there, there's just enough for it to take. You can see the wheels turning as we push it through by hand. Okay, so the strip itself, the laminate itself, wants to be in place and not touching the drum, whilst the sledge is supported by these lugs, which is about there. That's it. So I'll just put this piece of maple through, and I'll take the camera around a few angles, show you it as it's going through, and you'll see how it all works. That's pretty good. So there it is. It's the Sander Thicknesser MkII. Some excellent upgrades to the machine have made it much more accurate and easier to work with, really. So thank you for watching.